Hello, everyone, and welcome to today's SANS webcast, dealing with an adolescent cloud. My name is Jessica Gallus of SANS, and I'll be moderating today's webcast. Today's featured speaker is Ross Young. Ross Young is the CISO at Caterpillar Financial and a former Divisional CISO for Capital One, with a background in cloud, DevSecOps, and container security. He has led multiple organizations through digital transformations to the cloud. Ross is considered a subject matter expert in DevSecOps pipelines, as well as container Kubernetes security. He has a decade of experience within multiple government agencies, including NSA, Federal Reserve, and CIA. Ross is a lecturer for Johns Hopkins Whitting School of Engineering, as well as an associate instructor for SANS Institute. If during the webcast you have any questions for our presenters, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be made available for viewing later and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Ross.
Hi, everyone. My name's Ross Young. I'm super excited to be here with you. So I started thinking about the cloud and how old the cloud is, and it's kind of like a teenager. So I came up with this topic of, how do we want to deal with our adolescent or teenage clouds, and, what are things we need to do to, kind of ground them, almost like what you would do if a parent to get good behavior out of your children. And as I started to think about this, the first thing you have to remember is the cloud journey is inevitable, right? There may be certain people who aren't in the cloud today, but we're seeing a trend across the industry. We're seeing regulatory requirements from China and Europe saying, you need to keep our data in our country. So do you really want to have on-prem data centers all around the world? Or would you rather use a cloud provider and then use their regions and CDNs to enable your business? Additionally, if you maybe aren't in a traditional cloud provider, you might be using cloud solutions that come from software as a solution approach. You might be using GitHub, you might be using a Salesforce.com website, or a whole another slew of services. And if you're not already using cloud, you may feel pressure to. Your executives may be beating on your doors, or you just realize that cloud is the future and that's where you're going. So if you've struggled with hiring mainframe developers, maybe this is a way to change your hiring practices. So as we start to think about which cloud we want to go, normally an organization is going to start with a single cloud provider. You're going to have a huge contract, a huge vendor evaluation, and then you're going to choose something like Azure or AWS or whichever one you choose. It doesn't really matter. After you pick one, what you're going to find is it's never as simple as picking one. You have the 20 other SaaS solutions that start popping up, and you start to see elements of your organization who want something a little bit different. So originally, while your developers may have picked AWS because the extensive service offering from Lambda and S3 data and all these different solutions, maybe your desktop environment says, we've been a Microsoft shop for many years, and we love that experience. And the best way to do this is Office 365 and using Azure DevOps and some of the other services that are just native to Microsoft in the cloud. And so you spin up another cloud provider. But then maybe a different part of your organization, like your data scientists, say, we are very interested in image recognition or voice recognition and search queries. And so Google Cloud starts to pop up. And now you have to deal with identity management issues from 3 different cloud providers. How do you have effective data loss prevention solutions? And it gets very, very complicated quickly. So if that wasn't bad enough with the multiple cloud providers, What you also experience is the buzzword disruption of all these transformation efforts. Many organizations are adopting agile. You may have artificial intelligence or machine learning initiatives. You have cloud native technology of containers, of Kubernetes taking off. You have DevOps. How are we going to automate and deploy faster everywhere? And you have customers needing Internet of Things and bring your own devices and a whole slew of things that require different cloud strategies in order to appropriate apply security. So when I started looking at this problem and thinking about how do I want to tackle it, initially I was drawn to the AWS well-architected framework. And when I started looking at this and the number of best practices, I really felt quickly overwhelmed. I felt that there were so many different concepts and foundations and protections and tooling. It was hard for me to process and understand this. So I came back and I said, how can I make this simple? How can I keep it simple, stupid for myself to understand it and focus on a couple of key things that I wanted to do to help my organization? And I read another article, and you can actually get the link if you go to the subject line here and click it, on 7 design principles for securing the cloud. And this was something I thought could be achievable. This is what I want to see more organizations implement, enable, apply, automate, protect, keep, and prepare information in their organization. And we're going to dive on these because they give you the concepts in this article, but they don't show you how to do it. And that's why I'm here today, to give you some tools, some techniques, some processes that will allow you to perform each one of these essential design principles for securing the cloud. So let's start with the first one. How do we implement a strong identity foundation? So you're probably doing things like SAML integration and multi-factor authentication for your organization. And these are really, really good things to ensure proper authorization and authentication for your organization. And the key is restricting access control so that the good people come in and use your applications where they need to and the bad people don't. And how do we keep the good people from using services that they shouldn't? Through least privilege concepts and separation of duties and two-factor roles and things like that. So this is the focus. And as we start to think about how we might do this in AWS, here's a couple of tools that are very, very helpful. One is Action Hero, which is going to tell your developers what API calls are being made. And another one is, how do we simplify the IEM JSON documents that are a little bit hard to understand just how many roles we're providing to someone in the traditional ways of the create, read, update, and delete privileges that we're so used to seeing. So Action Hero is a tool by Anthony Barbieri, and I apologize if I'm getting that name wrong. What it allows you to do is run a process in the background. So for example, you can see right here at the beginning, we kick off the process, and then as people type in or perform certain functions, so here someone's performing an S3 bucket list, you can see, this event happened. And it tells you that your application needs the S3 list bucket permissions. This is really, really helpful. If you're an organization, your developers may be just focused on how do I get my job done? So they're going to do things in like shortcuts to say, just give my access EC2 star. And that's going to give around 300 different permissions to your application, including the ability to change things like the VPCs and other things that may not be appropriate for your EC2 instance. However, if we have our developers, run this as part of their QA test to say, really show me every privilege you need, and you utilize in your application, and I will give you all of those permissions. But I'm not going to give you one additional permission outside of what you're using. Now we've been able to implement this least privilege principle. And another tool that I want to show is a tool called Helium. Now, Helium comes from an application called Selenium, and this is a great way where you can do test cases. So if you look right here, somebody's typing in a simple line to start a Chrome browser. Then we're going to type in one-line command to enter the username and then the password, and then click the sign in. So why am I showing you this? If we enable our developers to create simple test scripts like Helium, we can prove out the functionality of their entire web application. Combining this with the previous tool, Action Hero, now we have the ability to see all of the features as well as record what were all of the required AWS privileges in the IAM roles. And now through these two things, we can really ensure that we have allowed each of the application privileges to remain. Another way that you can improve your IAM data that's out there is through these templates. I mentioned before that we may have things like EC2 star that are over provisioned. They provide too many accesses that your application doesn't need. And the same thing goes for S3 buckets, right? We do not want one application to have read writes for 500 S3 buckets if it doesn't actually use those buckets. And if that one application becomes breached for some reason, now the attackers have the ability to steal data from every one of those S3 buckets, which would be really bad. So a way we might do this is simplify the YAML templates we use to show permissions for our applications. So this is the CRUD example, the create, read, update, and delete permissions you're commonly seen before in a Linux or Unix-based system. And we can see that this application needs a read to this folder and it needs a write to this folder. And from this, it actually spits out the IAM YAML. And this is a lot more readable for your security architects or information security officers to look at on a per policy basis. They can quickly go through these two lines compared to, well, what does get parameters by path really mean? I don't know. What does SSM read parameter really mean? That's hard, but writing to an S3 bucket, that's pretty clear. I know exactly what that means. So I think this keeps it simple. It makes it easier for people to understand what permissions they're really enabling for their AWS applications. So pivoting to our second framework or design principle is how do we enable traceability? How do we ensure we can monitor, alert, and audit actions through tools such as CloudWatch and CloudTrail? And these are pretty commonly done. We're seeing people log everything. But if you log everything, what are you really looking for? How do we make sure we know what we need? And, you know, it's one thing to log everything, but are you actually automating anything so you have triggered responses? And how do you know which of the things you're logging are important that you want developers to take action on? Information is one thing, action is better. So this is where tools like Cloud Custodian, Scout Suite, and Prowler come in to really helping automate the information around our systems. So first of all, let's come back to what should we log? There's a great Twitter post where it actually identifies things like get secret values, password data, different key pairs, and other activities that would be helpful. Now, this isn't all-inclusive. This is simply a good start of different things that you can look for. And I put the full link in the notes of this slide so it didn't clutter the slide. I apologize that was a little small to read. Now, Cloud Custodian is another thing that can be really, really powerful. Cloud Custodian can watch different types of events and trigger specific actions through AWS Lambda jobs. So if you have a cloud formation script come in and it does things which would violate your security policy, you could block that cloud formation script from being applied. If you found certain actions happening, like opening public S3 buckets, you could instantly turn those off and be able to monitor and police your environment. So this tool that came from Capital One is a really great tool to look at how do we automate the different types of alerting and monitoring actions we want to do for an organization. Now, Scout Suite is another amazing tool that's been open sourced, which can be used in multi-clouds. It can be used on Azure, it can be used on Amazon and others. And what it allows you to do is you give it certain, let's say, read permissions to your entire AWS environment, and it'll check all of those settings to say, are we meeting the CIS best practices for AWS? So for example, there's certain ways you should configure CloudTrail, CloudFormation, AWS Config, EC2 servers to have things like encryption at rest, backup copies. This will go through those sorts of things and identify findings for people to check, which can be really valuable for an audit organization who may not be as technical as the developers. They can run a tool like this on a monthly basis, identify things that may not make sense initially. Now, just because there is a finding doesn't mean something's bad. If you have a public S3 bucket, that may be perfect for your public website. However, it could be very damaging if that was a private website. So using this tool as a way to dig into where might we be misconfigured, but not taking every finding at ground truth. You have to know the context around what you're searching for. Another example is how can we apply security at multiple layers? I think we've understood how important it is to patch an operating system. We've gotten really good at that. There's a lot of tools, Tanium, Microsoft, that just provide ways to patch our servers, right? We can use apt-get update and other things to enforce these things. However, where we may not be as strong is on the different layers. Do we keep our middleware up to date as much as we do our core OS? Do we keep our application frameworks like Apache Struts and other libraries fully up to date? Do we keep our Tomcat servers up to date, for example? And as we start to think about these things, I think there's something that I'm seeing in my mind that makes a good 1-2 punch. And that is, how can we use a vulnerability assessment tool or a vuln management tool commonly used like Qualis? Tenable Nessus is another example, or AWS Inspector, to get an inventory of all of these lower level OS and middleware patches. And then how can we use a runtime application self-protection solution that identifies those higher level application libraries and frameworks to make sure those are also patched? Well, we talked a little bit about AWS Inspector, but it really is the cloud version of something like a Qualis type tool. Now, it doesn't have the full functionality, but it does do a lot of things that are very helpful. You install an agent on your EC2 server, and it provides a continuous inspection. And you can use this to say, does my organization meet DISA compliance with all of the STIGs that you might need? Am I able to perform some type of security attestation against the CIS standards? And how do I identify common vulnerabilities and exposures that are on my instances where I could patch these things? And so there's another really, really good article that I won't dive into, but you can click to start reading more about automated AMI scanning. Now, Qualis, I mentioned this before, this is another tool that you can use to do asset inventory. And they have a free tool that you can use called Qualis Asset Inventory, where you can identify particular versions of applications with known vulnerabilities. And Contrast Security, while not free, does have an open source tool that you can use on one particular server. And Contrast Security is one of a number of RAS providers: Screen, Signal Sciences, T-Cell. There's a lot of vendors in this space. And what they can allow you to do is you install an agent like Qualis that will tell you specific libraries. So here I might see that my Tomcat server actually has 4 CVEs, common vulnerabilities and exposures, associated with this version. And it tells me you need to go to this newer version, right? And so this is really, really helpful to identify where we might be vulnerable and get an asset inventory of both the OS middleware as well as the higher level application libraries. So moving on to step 4 in the design principles, how do we automate security best practices? We need to look for fundamental things like locking down S3 buckets, but how do we step up our game? How do we identify the vulnerable passwords that might be in our source code? How can we identify bad license checks? How can we identify when we've misconfigured our AWS environment, not on a monthly scan like what we might do with Scout Suite, but how could we do this in a deployment pipeline? How can we identify when our containers and Kubernetes are misconfigured and don't have all of the strengths that we might use to ensure good, solid pods in our deployment infrastructure? Well, let's take a quick example of this. Starting with Shift Left, they're one of a few different SAST vendors. They provide an open source tool that organizations can use to scan their code for software composition vulnerabilities. They can also identify different licensing issues, as well as perform a SaaS-based scanner. And this is a free tool if you go through the open source version on the link here. And where I'm seeing a shift is, instead of putting it into a full pipeline, how might we integrate this with a simple GitHub action so that we enable our developers to find vulnerabilities faster? When we find them faster, we save a lot of time that would come from all the rework of fixing bad code later on in the production lifecycle. So this is another great free tool if you're an organization strapped for cash on how I could do a lot of things with just one tool. Now, Checkoff is another tool that you can use to look at your infrastructure as code for vulnerabilities. So if I'm writing a Terraform file, right, how might I identify if this Terraform file has vulnerabilities or doesn't follow the CIS best practices? And if I can use this attestation, I can show auditors, I can show security organizations the trust that I've built by building solid code. And Terrascan's another really good product in this space that just recently came out. But what a lot of these tools do is very similar to what we just saw with the Shift Left tool. There might be a GitHub action where you configure a couple of settings. You tell it where your code is, you tell it what you're going to run, and then you have sample reports that identify specific findings. Maybe you didn't encrypt something, maybe you're not backing up something, maybe something is publicly available when it shouldn't be. Maybe you're not using things like EC2 tags to say who the owners of your applications are, which is helpful for when something breaks and now you need to call somebody. All of these types of architectural issues and governance and best practices are things we can start to look at through some of these automation tools. Another example of where the security best practices come into play is through protecting data in transit and rest. Now, you've heard it before that we need to encrypt things at rest and we need to use strong encryption like TLS 1.2. I'm not going to dive into that. It's pretty well known that these are things you do. Even if you don't want to do them, there probably is a legal or regulatory compliance to ensure that you do them. So how do we step up our game? How do we do something even cooler? We might look at required web application firewalls. VPC flow logs, guard duty, config? How do we ensure we have really, really good configurations? How do we identify different types of data that may be problematic, right? Our PCI, our HIPAA data, making sure we're using test data or we're encrypting this data and tokenizing this data to meet all of our relevant required frameworks and legal compliance things like PCI and HIPAA. So AWS Config is a one-stop shop for AWS compliance. There are other tools like this, but what it allows you to do is look at the managed rules you have for your organization on things like encryption, on things like guard duty to see where things are leaving in more of a DLP type approach. Have we rotated our secrets? Are we using Shield for DDoS prevention and WAF? Are we using VPC flow logs? Each of these ways are things where we can ensure our organization follows things like best practices. And it's not easy. It's going to take time to train the organization to start to filter out the misconfigurations. But as we do this, we're going to really improve our cyber hygiene. Now, how do we keep people away from data, right? How do we reduce their access? Nothing is worse than people within our organization who quit, who still have access to our data, right? We need to ensure that doesn't happen. Or maybe they're still in our organization. They went from being a developer of our credit card application, where they needed a lot of accesses, to being the developer of the lunch card application, where they probably don't need any accesses to this payment data. So how might we remove these things? How might we revoke their access to production to prevent some of these insider threats? And we need to change our perspective. Historically, when things go wrong, developers believed and really focused on, well, I need RDP, I need SSH into the box so I can troubleshoot these things. Well, these pose security risks to our organization. One is, if any of these credentials are lost, well, now we've just enabled an attacker to get on our box. So think about this. If somebody spearfishes one of your developer population, and then they look on that subject's machine and simply grep through the various CLI commands that have been incurred, might they find an SSH key into our production server? We really haven't made that too hard for them. Are we using things like CyberArk or other things which might be much harder for them to have that access because they would still need to log in and authenticate through an MFA approach before they can go into production? And as we look at it, where we started to see a shift is, what if I turned all of these things off? Developers had no remote access to production boxes. Well, if things went bad, what would a developer need to do? They would need to figure out what doesn't work. Well, I can log that. And if I can log that, then I don't need these different types of accesses. And we can look at those types of events. So one way I can identify people who are leaving the organization is through IEM Access Analyzer. And Bridgecrew just kind of came out with another tool that is very similar. And what it allows you to do is you can use IEM Access to monitor a variety of different functions of roles, buckets, lambdas, queues. And we can identify a last used timestamp. And what we can do is we can start to say, hey, if something isn't used in 90 days, you need to tell me why I shouldn't revoke this because it's not active. Now, there may be times when you want these privileges to remain. So for example, you may have a forensics team that needs to log into your entire environment anytime an incident happens. Now, they're not going to log into the entire environment every month because there simply isn't an incident. But we want to enable them to be very, very fast. Now, not everybody needs this access, so that's why you're going to look at it on a case-by-case basis. But a lot of places may not. You know, hey, this is a team where they were just having a variety of data scientists set up some servers. They said, I need access to everything. And you wanted to help them be, you know, effective. And so you gave them those temporary accesses to set up everything. But now that you've been monitoring their application, you use things like Action Hero and others, you can start to look at, well, let's pull back the reins a little bit. Now that we know what you built, now that we know what it really requires, let's scope that to have least privilege. And when we start to look at security events, remember, things happen, right? There is no perfect security. People will fuzz your website. People will attack your website, particularly if they think they can steal money or run Bitcoin servers or, cause ransomware attacks that you're going to pay money to. So when those things happen, it's important to have incident response plans. It's important to go through tabletop exercises and a variety of different things that would help you as an organization. So in the PowerPoint here, I've given a couple links to AWS's guides that can be very, very helpful for your organization. So I've kind of gone through the information very quickly here. I wanted to save some time for a Q&A section to really talk about these 7 different items that we mentioned before and see if there were questions on these things or, discussion topics where we can identify ways to better enable organizations through simple processes and tools that don't really cost a lot of money, but can really secure a lot of our infrastructure. So now at this point in time, I'd like to turn it over to do a Q&A. So if you have any questions for me, I will be responding to each of the questions here. Please submit your questions.
All right, thank you. As we wait for some questions to come in, let's see. We have a question here. It says, what type of security misconfigurations are most common as per your experience?
So misconfigurations can mean a lot of different things for folks. I think the most common is the over provision of access, right? That this one server has access to so many S3 buckets that it really doesn't need access to. That's probably the biggest one that I see. I think most of the easy low-hanging fruit of don't have public S3 buckets are really starting to disappear. That was kind of big about 2 years ago. So I would say the biggest misconfiguration that I'm seeing is those common over privileges, as well as a lack of understanding for how CDN networks work. So we may use Lambda at edge in an AWS environment to really allow developers the opportunity to have the lowest latency to providing data to end customers. But if you run at a on-edge environment, you don't have the ability to run a traditional WAF. You're pretty much stuck with AWS's WAF or nothing. And so I think those sorts of things are where the misconfigurations can happen, because people don't understand, how do I have good security around those types of environments?
Okay, great, thank you. The next question is, how do you see the future of cloud native WAF evolve as runtime container security takes priority in the next coming months and years?
I think a cloud native WAF is really going to become much more the standard, because it allows you to have something that auto scales in conjunction with your traditional servers. So whether you're using an EC2 server, a ECS for basic containers, EKS, Fargate, or a serverless approach like Lambda, the AWS WAF allows you to operate in any of those environments, and it doesn't have the scaling issues that traditional servers may have. In addition, if you're using an event-driven architecture where things die down, that allows a lot of cost savings that'll happen. So I think this is really where I expect the industry to pivot. However, the hard thing with a cloud native WAF is it's really good for one cloud. But as soon as I have three clouds, I have an Azure cloud, I have an AWS cloud, I have an Alibaba cloud, and I have an on-prem cloud, how do I standardize that cloud experience with WAFs to ensure I have the same level of protection? And that is very difficult to do. Additionally, I don't think some of the cloud native WAFs may have the same maturity. So how can we do a vendor assessment to say, just because I've turned on a WAF, is it functioning the way I want it to? Does it block 3 of the OWASP top 10 attacks, or does it block all 10? And does it have a true positive rate of 80%, or I'm in the 30% where it's an illusion of what it's really keeping me safe from? And so this is why I think you need a defense in-depth approach with a RASP, a WAF, and other tools to really limit and scope access.
All right, great, thank you. That's all the questions that I do see as of right now.
Okay, well, I want to thank everyone here who had the chance to come and attend. Please take the opportunity to go and download the PowerPoint. Like I said, I put in a lot of really good let's say, reference material, either by clicking the links inside the web page or reading on the notes pages. It'll be a really helpful thing for you and your organization. And I just hope I provided some value to someone who's been thinking about some of these problems. And, I'm very active on LinkedIn if you want to get in touch with me, as well as there's classes from SANS that help teach these sorts of things, particularly in the cloud security track. We have a 540 class to teach DevOps. We have a 540 or 584 class that does some of these multi-cloud environments. We have a cloud pen testing class. So there's really a lot of good classes to go to get additional training to improve your security knowledge and spend a week just gaining some mastery over these domains.
Perfect. I actually did see a question just come in. So it says, do you have any good tools to reference to visualize serverless flows in the application?
Visualize serverless flows. So there's a couple of things that you can do for visualization. One is things like Terraform have the ability to show how your whole infrastructure maps to itself. So you can use that as a way to visualize some of the connections. Now, serverless gets a little bit tricky. I don't think I've actually seen a lot of Lambda to Lambda visualization tools. That tends to be in different areas. Perhaps you could put that together from some type of Redis graph with your logging data. I haven't seen any tools out of the box to really show that.
They were mentioning about they were struggling with app traffic visibility. I don't know if that helps a little bit.
So with application traffic visibility, it really depends on what part of the OSI layer you're talking about. From the external most layers, you can use things like NetFlows and VPC logs. However, if you're looking for applications, and we're not talking specific to serverless, this is where I think a lot of the RASP tools really shine. They will have visualizations that show the connections between all of your systems of where they're receiving data to and from. And that can be extremely powerful in understanding, wow, I didn't realize this application had this connection to this other one. So look at those RASP applications as well as things like Terraform. There is some visualization tools inside of Terraform that you can use to take your Terraform file and map that out. Cloud Mapper is another tool that kind of does this, where you can start to see, how things connect, what ports are open, what firewall rules you've opened for your connectivity between your applications.
All right, great, thank you. So that's all the time that we do have for today. Thank you to our speaker, Ross, for that great presentation, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcast. Until next time, take care, and we hope to have you back again for the next SANS webcast.
Thank you, everyone.